Module 18.4 Day 1 Problem Solving with Trigonometry Content Standard Using trigonometric ratios and the Pythagorean theorem to solve the right triangles in applied problems. Language objective. Explain to a partner how to solve a right triangle and how to solve a right triangle in the coordinate plane. Using the area formula. Area formula for a triangle in terms of its side lengths. The area of triangle ABC with sides AB and C can be found using the lengths of two of its sides and the sine of the included angle. So area equal to 1/2 BC times sine A, or area equal to 1/2 AC times sine of angle B, or area equal to 1/2 BC times sine of angle C. Right, so the trick here is that the two sides and the angle must be in between the two sides, and we can use any of those three combination. Right? You can use any form of the area formula to find the area of triangle given two side lengths and the measure of the included angle. Okay, example 1. Find the area of each triangle to the nearest tenth. So we have the two sides and the angle in between that. So we say that the area is equal to 1/2 3.2 times 4.7 times sine of 142 degrees. And from there, just use your calculator to work this out. Okay, so this gives us 4.63, and then its area, so it's meters squares. Okay, and example B, sketch the triangle DEF and check that angle D is in the included angle. So here we have our sketch. Find the area of triangle DEF. So we say that the area is equal to 1/2 9 times 13 times sine of 57 degrees. And from there, everything is going to be on your calculator. Okay, so this gives us 4.9, and in terms of area, so then it's inches squared. Right, okay, let's go on to number 3. So I'm going to have you guys try these two on your own, and I'll give you the answer in a minute. Let's go back to this one here. I think I made a mistake, so let's change this. 0.5 times 9 times 13 times sine of 57. This gives us 49.06 inches squared. Okay, so let's go back to these. So then the angle is in between the two sides, so we can say that the area equal to 1/2 times 12 times 15 times sine of 34 degrees. So this gives us 50.32 millimeters squared. Right. Number 4, in triangle PQR, PQ is 3 centimeters, QR is 6 centimeters, and angle Q is 108. Find the area. So we're using the formula, so it's 1/2 times 3 times 6 sine of 108 degrees. So this gives us 8.56 centimeters squared. Right? Solving a right triangle. Solving a right triangle means finding the lengths of all its sides and the measures of all its angles. To solve a right triangle, you need to know two sides lengths or one side length and a acute angle measure. Based on the given information, choose among trigonometric ratio, inverse trigonometric ratio, and the Pythagorean theorem to help you solve the right triangle. Okay, so let's go through some review here. Right? So we can say that we can use tangent of an angle is opposite over adjacent, and sine of an angle is opposite over the hypotenuse, or cosine of an angle equal to adjacent over the hypotenuse. Okay, and an easy way to remember this is that we can use this sentence. We see that the cat sat on an orange and hurt himself, right? So T stands for tangent, C stands for cosine, and S stands for sine. So tangent is opposite over adjacent, and cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Okay, and to find the angle, so the angle is equal to tangent inverse opposite over adjacent, and similarly if you use sine, then the theta equal to sine inverse opposite over hypotenuse, and you use cosine, then it will be cosine inverse adjacent over hypotenuse. And the Pythagorean theorem is a squared plus b squared equal to c squared. Right? Okay, so these are all the formula we need. Okay, so let's try example A. A shell extends perpendicular 7 inches from a wall. You want to place a 9-inch brace under the shell as shown. To the nearest tenth of an inch, how far below the shell will the brace be attached to the wall? To the nearest degree, what angle will the brace make with the shelf and with the wall? So here we're given that this is 7 and this is 9, and so this is one of the leg, and this is the hypotenuse, and we need to solve for this part. So let's call that x, right? So then we said BC squared plus 7 squared equal to 9 squared. So then BC squared equal to 9 squared minus 7 squared. So this gives us 32. So then BC equal to square root of 32. And they wanted to right to the nearest tenth of a, okay, so this gives us 5.7. So x is 5.7. Okay, so then to find the measurement of angle B, right? So we said that to measure angle B, so if we were observing from this angle, so we have opposite, adjacent, and hypotenuse. So we have all three measurements. We can use any measurement we want. So let's say we want to use sine. So then we will work with opposite and hypotenuse. Right? So then we said this is sine inverse of 7 over 9, and then from there use your calculator. So this gives us 51 degree, because they wanted to the nearest degree, and that means that angle A equal to 90 degree minus 51. It gives us 39 degree. Right, so then that's cover part B. Okay, so now your turn. A building casts a 33-meter shadow when the sun is at an angle of 27 degrees to the vertical. How tall is the building? To the nearest meter. How tall is it from the top of the building to the tip of the shadow? What angle does a ray from the sun along the edge of the shadow make with the ground? So number 6, use trigonometric ratio to find the distance from E to F. So we're looking for the distance from E to F. We're observing from this angle, so we have opposite and hypotenuse. So opposite and hypotenuse, we use sine. So we use sines of 27 degree equal to opposite 33, and hypotenuse is EF. Right, so that means that EF equal to 33 over sines of 27 degree. So this gives us to the nearest meters, so it'd be 73 meters. Number 7, use another trigonometric ratio to find the distance from D to F. So D to F is this part here. Right, so let's call that Y. So then we're observing from opposite and hypotenuse. So opposite, oops, I think I made a mistake on number 6. Let me erase that. Okay, let's go back to number 6. We're solving for EF, so we have opposite and adjacent. Okay, so that's use tangent. So tangent of 27 degree equal to opposite over adjacent. So then EF. So then EF is equal to 33 over tangent of 27 degree. So this gives us to the nearest, so it will be 65. And in terms of meter. Okay, number 7 is we're looking for opposite. DF is the hypotenuse, so this will be sine of 27 degree equal to 33 over DF. So then DF equal to 33 over sines of 27 degrees. So then we said we worked this out to be 73 meters. Right, and for number 8, use the fact that acute angle of right triangles are complementary to find the measurement of angle D. So then the measurement of angle D equal to 90 degree minus 27. So then it's 63 degree. Right, okay, so let's continue with these. Use a calculator and invert trigonometric ratio to find the unknown side lengths and angle measures, round lengths to the nearest hundredths, and angle to the nearest degree. So we're looking for side AC. So this part here, since this is a right angle, so we can use the Pythagorean theorem. So we can set x squared plus 4 squared equal to 5 squared. So x squared equal to 5 squared minus 4 squared, which gives us 9. So then x is equal to 3. So then AC is 3. Right, and to solve for angle B, so this is 3. So let's say we're giving these 2. So we have adjacent and hypotenuse. So we can use cosine. So we do cosine of angle B equal to adjacent over hypotenuse. So that means that B equal to cosine inverse 4 over 5. And from there, just use your calculator. So this to the nearest degree, so that we can round this up to 37 degree. To solve for C, we take 90 minus 37. So it will be 53 degree. Right. Okay, let's go to number 2. So we're given that F is 51 degree, we can solve for D. So D, you take 90 minus 51. So this gives us 39 degree, right? Okay, so we're observing from F, so then we're solving for DE, so then this is opposite and adjacent. So then opposite and adjacent, we can use tangent. So we do tangent of 51 degree, opposite is DE, over adjacent 18. So then DE equal to 18 times tangent of 51 degree. So to round to the nearest side length. Right? Okay, so this is 22.23 and in terms of feet. Right? Okay, so then to solve for our EF, so then this part here, right, so observing from okay, let's go back to DE, another mistake. So that's a right angle, so that the hypotenuse, we see that it was 39 degrees. So we have opposite and hypotenuse. So when we use sine, sines of 51 degree equal to DE over hypotenuse, which is 18. So then DE equal to 18 sines of 51. So we can round this up to 14. Right? Okay, so let's go on to our next one to solve for EF. So this part here, so we're observing from this angle, so we have adjacent over hypotenuse, so we use cosines of 51 degree adjacent over hypotenuse. So that means that this is 18 cosines of 51 degree equal to x. So this is 11.33. And we said angle D was 39 degree. Okay, so then let's work with number 3. So we're looking for GX, so then this point here, right? So then since it's a right triangle, so we can use the Pythagorean theorem. So we said 15 squared plus x squared equal to 17 squared. So then x squared equal to 17 squared minus 15 squared. Which is 64, so the x equal to square root of 64 gives us 8. So this is 8. Okay. And then now to solve for angle H, so from here, so we have opposite and hypotenuse, so we can use sine. So then sine of angle H equal to opposite over hypotenuse. So that means that H is equal to sine inverse of 15 over 17. So then we can round this up to 62 degree. To solve for I, so it would be 90 degrees minus 62. So then I is 28 degrees. Right, so then that's the end of our 18.4 day 1 notes. So your bookwork is number 1 through 5. You have new HRW, and you are to copy down 18.4 day 2 notes.